This tutorial is brought to you by PE Prep Engine. Free study guides and practice questions at peprepengine.com.
Week 3, Lesson 1, Fillet and Butt Welds. Mechanical attachments opens with the most common connection on the exam, the welded joint. Two families do all the work. A fillet weld lays a triangular bead in a corner. A butt, or groove weld, fills the gap between two inline plates. The whole lesson turns on one habit. A fillet is drawn by its leg, but it carries load across its throat, and we check that throat in shear, no matter which way the load pulls. Get the throat and the shear right, and the weld problems on this exam become arithmetic. Here's the problem. A lap joint carries a static tensile load through two parallel fillet welds. You're given the load, the weld leg size, the length of each weld, and the electrode. Find the shear stress on the throat, compare it to the code permissible shear, and report the factor of safety. 2 handbook pages hold everything: the types of welds chart and the tables of electrode strength and permissible stress. Concept 1. 2 weld families. A fillet weld is a triangular bead tucked into a corner on a lap or a T-joint. It needs no edge preparation, so it's cheap and it's everywhere. It's drawn by its leg size, but it fails across its throat. A butt or groove weld fills a prepared gap between two aligned plates. Here, the weld simply is the plate section, so its size equals the plate thickness, and it carries the full cross-section. The fillet, with its throat subtlety, is the one worth working through. Concept 2, the heart of the lesson. A fillet is a 45-degree right triangle with equal legs, and the shortest plane through it, the throat, sits at 45 degrees. So the throat equals the leg times cosine 45, about 0.707 of the leg. That throat is the failure plane, and the design convention is to treat the load on it as shear, whether the load runs across the weld or along it. One habit for every fillet. Because it's shear, you compare against the shear permissible value 4/10 of the yield strength, not a tension value. A footnote you should carry: the chart prints these formulas with a sigma, its symbol for a normal stress. But fillet practice reads that throat stress as shear. That's why the comparison is to the shear row. Concept 3. Match the case to the geometry. A standard lap joint runs 2 parallel fillets, so the load splits between them, and the chart form is 0.707 P/HL, the 2 throats already baked in. A single fillet doubles the stress, 1.414 P/HL, which is just the load over one throat. And a butt weld carries the full plate section, so it's simply P/HL. Read the picture, pick the case, and never mix a parallel formula onto a transverse joint. Setup. 1 shear check in 4 steps. First, the throat area of the 2 welds. Second, the shear stress on that throat. Third, the permissible shear from the AISC table, 4/10 of yield. Fourth, the factor of safety, allowable over applied. The table holds the load, the leg, the length, and the electrode yield. The only conversion is the load into newtons, so the stress comes out in megapascals. Solve. Part 1. The 2 throats give a total area near 1400. Divide the load by that area, and the throat shear is about 70. And the chart's 0.707 form lands on the very same number, because that coefficient is just the 2 throats written on top. One conversion only, the load into newtons. Solve. Part 2. The AISC table permits 4/10 of the electrode yield in shear, giving an allowable of about 157. The factor of safety is allowable over applied, about 2.2. Applied shear sits well below the allowable, so the weld passes with room to spare. And be honest about what that number means. It's the margin against the code allowable, not against outright yielding. The 4/10 already carries the code's own safety factor. The answers: throat area about 1400, throat shear about 70, permissible about 157, factor of safety about 2.2, safe. If the exam instead asks for the required leg, invert the same relation and solve for H. Same 3 numbers, different unknown. Traps. 5 ways the weld check bites. 1. The signature miss, using the leg instead of the throat in the area. The throat is 0.707 of the leg, and dropping it makes the stress read almost a third too low on the dangerous side. 2. Forgetting there are two welds. The standard lap joint shares the load over both throats, and the chart form already carries the pair. A single weld doubles the stress. 3. Comparing to the wrong permissible. The fillet throat is in shear, so 4/10 of yield, not the 60% tension row the chart sigma tempts you toward. 4. Treating a butt weld like a fillet. A butt weld carries the full plate section, no 0.707. 5. Mixing chart cases. Match the geometry to the formula before you reach for it. Quick recall. The throat area is 0.707 times the leg times the length per weld. Two parallel fillets give 0.707 P over HL. A butt weld carries the full section, P over HL. Permissible shear is 4/10 of yield, tension 6/10, and an E70 electrode yields 393. Golden rule: size by the leg, fail on the throat, and check a fillet in shear against 4/10 of yield. Next up, Lesson 2, Welded Joints in Bending and Torsion. This lesson pulled the loads straight through the weld, so the throat shear was uniform. But brackets and shafts load a weld off-center, and the throat then carries a moment too. Lesson 2 builds the unit's second moment properties, adds the primary and secondary shear vectors, and finds the worst point on the weld group. Everything's at PEPrepengine.com. Cheat sheet, worked solution, and a quiz attached here.
The full study guide, with every equation and common exam trap, is free at PEPrepengine.com. Link in the description. Machine design, HVAC, structural, civil, and electrical series are coming soon. Subscribe so you don't miss them.